talking about parallelism, okay? And all that means is vectors that are parallel. So if I have a vector A, um, I can have vectors parallel to it that are of different lengths. In other words, 2 times A or 1/3 times A are still parallel to vector A. So two non-zero vectors are parallel if and only if one is a scalar multiple of the other. Scalar. Scalar you can think of as just a number. Is 2A a multiple of A? It certainly is. Is 1/3 a multiple of A? It sure is. Okay, so since they are multiples of one another, then they are parallel. A is a multiple of 2A in that if I took 1/2 of 2A, I would get A. All right. If we have any non-zero vector and non-zero scalar k, some constant k, remember scalar is just a number, the vector k times v is parallel to v. So if vector A is parallel to B, then there exists a scalar k such that A is equal to KB. In other words, there is some number I can multiply B by to make it the same length as A, or the exact same value, equal vectors. Looks to me like maybe, I don't know, that B is about half the length of A, and if it was, if I multiplied it by 2, it would be equal to A. That's all that this says right here. Is I can take, if I have parallel vectors, I can multiply either one by some scalar number so it's equal to the other one. Okay, so let's do an example for R and S, or find R and S given that vector A equals 2, -1R. And is parallel to B equal to S to -3. Well, if this is true, if they're parallel, then there is some value k multiplied by this vector to S, okay, so S to -3, such that the vectors are equal. So what you're looking for is corresponding components that are numbers and not variables, and we have that right here. What we have is -1 equals 2 times k, which means that k is equal to -1/2. Well, if k is equal to -1/2, then 2 equals -1/2 times s, replacing k with -1/2. 2 equals -1/2 times s. Dividing by -1/2, -4 would equal s. Okay. What about r? Well, r would equal -1/2 times -3 because r is the corresponding component to -3. So r would equal +3/2. So that is no big deal there. Okay, moving forward. Unit vectors. Remember, unit vectors have a magnitude of 1. That is the requirement for a vector to be a unit vector. So if I have a non-zero vector v, its magnitude is a scalar quantity. We know that it's a number. If we multiply v by the scalar 1 over the magnitude of v, we obtain the parallel vector 1 over magnitude v times v. The length of this vector is 1. It will always be 1. Let me show you real quick. Let's just do a two-dimensional vector. Let's say I have a vector 1, 2. Okay? So the magnitude of v would be equal to square root of 5, wouldn't it? 1 squared plus 2 squared. So if I take 1 over the magnitude, 1 over root 5 times 1, 2, then I get 1 over root 5, 2 over root 5 for a new vector. Yes? And what is its magnitude? It's the square root of 1 over root 5 squared plus 2 over root 5 squared. Hopefully you're seeing what's happening. So this is the square root of 1/5 plus 4/5, which is the square root of 1, which is 1. So we have a unit vector in the direction of the vector v. Now remember, vector v is 1, 2. But if I need a unit vector in the direction of v, what does 1, 2 look like? 1, let's see, 2 looks like this. And it has length square root 5. So what I just found is a unit vector of length 1 in the same direction as vector v. Hopefully that makes sense. A unit vector in the direction of vector v is 1 over root magnitude of v times the vector v. A vector b, so a different vector, of length k in the same direction as a is k over magnitude of a times a. And parallel, it could go in either direction. Now remember, parallel, if I have a vector going this way and a vector going this way, they are parallel because there is some number I can multiply this by to get it to be equal to that. I can multiply it by a negative number. Okay, almost done here. If a equals 3i minus j, find. I kind of like to work in component form. So this would be 3, negative 1. A unit vector in the direction of a. So remember, to find a unit vector in the direction of a, I take 1 over the magnitude of a times a. So that would be 1 over square root of 3 squared plus negative 1 squared is square root 10. And I'm going to multiply that by the vector a, which is 3, negative 1. So that would be 3 over root 10 times negative 1 over root 10. Is that a unit vector? Well, if you square this, you get 9/10. If you square this, you get 1/10. 9/10 plus 1/10 is equal to 1, and that's under a square root, but the square root of 1 is equal to 1. So we've done it. We've found a unit vector in the direction of vector a, because we just did a multiple of a. Of course, you could also write this in unit vector form, 3 root 10i minus 1 root 10j. Put in my vector signs. Okay. B, a vector of length 4 units in the direction of a. Well, all I have to do is take 4 times this. So 4 times 3 root 10 negative 1 root 10 would be equal to 12 over root 10 and let's see, negative 4 over root 10. Make my little home there a little bit better. Erase that. Okay. Then do this, which I could also write as 12 root 10 I minus 4 root 10 j. Okay. And then let's see, vectors of length 4 units which are parallel to a. Okay. Now let's go back. Why is this of length 4? Well, it's of length 4 because this is a unit vector. The unit vector is length 1, so if I multiply it by 4, then it's going to be of length 4. So a vector is of length 4 units which are parallel to a. Well, we already have one of them, 12i over root 10. The I should go here. 12 over root 10i minus 4 over root 10j. We just did that one. The other one is parallel going in the opposite direction. Negative 12 over root 10i plus 4 over root 10 times vector j. Okay, all I did is negate the first one. That means it's going in the opposite direction. And the final example, find a vector b of length 7 in the opposite direction to the vector a. So of length 7, if it's a length 7, I want to take 7 times a unit vector in the direction of A. So to find a unit vector in the direction of A, I have to take 1 over the magnitude of A times A, which is going to be 1 over the square root of 4 plus 1 plus 1. So that's going to be, I squared all those, so that's going to be 1 over root 6 times 2 negative 1, 1, which is equal to 2 over root 6, negative 1 over root 6, and positive 1 over root 6. Okay? And so this is the magnitude of 1 right here. So to make it a length of 7 and in the opposite direction, I'm going to take negative 7 times, the negative makes it go in the opposite direction, 2 over root 6, negative 1 over root 6, and I never make these bracket things big enough, 1 over root 6. Okay, so what does that equal? That equals, negative 2 times 2 is negative 14 over root 6. Negative 7 times a negative, that's a positive 7 over root 6. And then a negative 7 over root 6. How could I check my answer? Well, ooh, that's horrible. The directions say a vector of length 7 in the direction of A, or in the opposite direction. Well, we know it's in the opposite direction. We multiplied by a negative. But if it's of length 7, that means the magnitude of this must be equal to 7. Well, negative 14 over 6 squared is positive. 14 squared is 196 over 6 plus 49 over 6 plus 49 over 6. Okay, so that's going to be equal to the square root of let's see, 49 and 49 is 98. 196, so 294 over 46. 294 over 6, I didn't say 46, which is equal to the square root of 49. 6 times 49 is 294, which is indeed 7. All right, that is it. I am out!